If you're writing code where your high-level business logic is manually creating instances of low-level classes using the new keyword, you're building a trap for yourself. Today we're going to fix that by learning the Dependency Inversion Principle. Let's look at a common scenario. You have an order service that needs to send a receipt. In the constructor, you directly type new email sender. This works, right? Well, technically, yes. But you have just tightly coupled your high-level order logic to the low-level detail of sending emails. Your order service now knows too much about how emails work. But what happens when the requirements change? Suddenly, you need to send SMS receipts instead. Or maybe you want to write a unit test, but you can't, because every time you run the test, the code tries to send a real email. Because you used the new keyword, you can't swap that email sender out without rewriting your class. You're stuck. This brings us to the D in SOLID, dependency inversion. The rule is simple. High-level modules, like your business logic, should not depend on low-level modules, like database connections or email services. Instead, both should depend on abstractions. Think of an abstraction as a contract or an interface. It describes what needs to be done, not how to do it. Think of a wall socket. Your house doesn't need to know if you're plugging in a lamp or a laptop. It just provides a standard interface, the socket. If you hardwired your lamp directly into the electrical wiring behind the wall, you'd have to tear down the wall just to move the lamp. That is what newing up dependencies does to your code. It hardwires it. Here's the fix. First, we create an interface called iNotifier. Then, instead of creating the dependency inside the order service, we ask for it in the constructor. This is called dependency injection. Now, order service doesn't care if it gets an email sender, an SMS sender, or a fake sender for testing. It just knows it has something that can notify. By inverting the dependency, you regain control. Your code becomes loosely coupled, meaning you can change the low-level details without breaking the high-level logic. Your tests become faster and safer because you can inject mock data, and your application becomes easier to scale. Stop hardwiring your code. Start using abstractions. If this explanation helped clarify the dependency inversion principle for you, please drop a comment below and subscribe for more architectural tips. Thanks for watching.